Now let's also implement this function that we have designed. So this is the function that we have done for the majority detector, and we went through how to define the truth table, K-map, and how to square the ones in order to get the functions. So, but okay, let me here it should be 0, should be 1, 2, and 4 because it's power of the n. So if 0 is 1, so let's now try to implement this function on the quarters. So we have a Verilog file that is the neuron, so we're going to add that function here. That function is majority detector. So let assign it first. So let's declare the majority detector. So we have merge detect, and then this is majority detector is an output of single bit, merge detect. So let's assign it now here. So assign merge detect. So our first term we had for the majority detector function f is d0, and then we end it with d1. That was the function, and then plus. Or, so we're going to use OR here, but I'll show you what happened if we use plus. But it is the same. So OR with d0, we end it with d2, and OR d1, we end with d2. So this was the function that we had. So let's try to analyze and synthesize to see if we did everything correctly. Now you can see everything is correct. So let's try to implement this neural model now to our test bench. So we need to add this majority detector on our test bench file. So on our test bench file now we had, so this is the model. Now we have a new function that is majority detect. So let's just copy this majority detector so we don't write it wrong. Majority detector. So we need to implement it here. So it's majority detect. Then T. Now we need to check it, majority detector. So how you're gonna check if it's correct? So we're gonna do the same approach. So if we're gonna test, it's basically we're gonna write the same function. If majority detect is not equal to our then writes. If you remember, our then write is, for example, d0. So we need to do the same thing that we have did here. So parenthesis. For example, our d0 is gonna be this one. So this is d0, and then we need to AND it D0 and with D1. So this is D1 and then is OR D0, and then we AND it with D2. So D2. So remember, because the then right is X and with W. So now this is D0 D2 or D1 D2. And D2. So we're gonna display fail model if it's fail. So display fail match detect, for example. So if this one fails, we're gonna display majority detector. So if the majority detector is not equal to this one, so let's save it and analyze and synthesize once more. We don't put your test bench as top level event tree. So you can see now it have run correctly. Now let us launch the ModelSim, so RTL simulation. Now if you go so you need to compile it. Compile both Neuron and Testbench file. Go to work, simulate the Testbench, and then add to wave if name. So this is our brain rights and our axons and synapse. We can try to simulate this nanosecond, but let's simulate it all at once, see what happened. Simulate all, run all. No. So you can see it didn't fail, and we have a majority detector. Yeah. So we can try to add a majority detector to see if the function is 1. What is the function name? We can do that by go to our test bench file here. If you want to look at our function name, so how we can do that, we can add here. We have a count, so you can see merge detect, and then this is 1 decimal, so 0D, and then we're gonna have our merge is test bench merge detect. That should be it. Yes. Save. Go to our quotes. So we update it and recompile again and try to run it all. No. So now we can see how your majority detector. So now we can see that when the axon and synapse are 1. So for example, here we have the then right is always 1 1 1. So we have 1. So we can see the function majority is working. So you can see here we have 2, for example, and this is 1. So clearly you can see, for example, all of these are 1. Now it's easy to see from here. So we can see we have a majority detector here, here, and here 4 times, as we did on our truth table. So we can see clearly majority detector is working, and this is how you will test it, your function, what kind of function that we have. This is how you test it. So you can see this is our Verilog file, testbench file, and here wave simulations. If you even try to look at it, you can see it here, majority detector, how it's detecting. So that's for this video. So we went through how you can design a testbench file, a neuron model. We went through all the neuron model that we have designed. So from this, how you went from this one to design a silver neuron model on this Verilog file. So in the next video, we're going to talk about other concepts, for example, like time simulation, and try to implement this on hardware.